The substitution technique is a method of changing certain complicated integrals into simpler ones that we can use our known integration rules on. So here's how the substitution method works. We're going to take this integral and we're going to take the 3x plus 4 and call it the letter u. That means in place of the 3x plus 4, we'll be substituting a u. Now, if I was doing the integral of u to the 7th power, that would be easy. That's the power rule. However, before we can do the integral of u to the 7th power, we cannot have a dx beside it. Now, the process then looks like this. Once I've chosen the u equals 3x plus 4, I need to do the derivative of that. The derivative of 3x would be 3. The derivative of 4 would be 0. And then I need to do a little algebra to rearrange that. I'm going to multiply both sides by dx and divide by 3. So, according to this, I can replace the dx with a 1/3 du. Now, this is an integral which I can do. I bring down the 1/3, use the power rule on u to the 7. We're almost there. We can do a little simplifying. The 3 and the 8 can be put together. And then we change the u back into 3x plus 4. And that's our answer. Now this one follows a similar pattern to the first one. We're going to choose u to be the stuff in the parentheses. That means we'll be replacing the 2x cubed minus 3 with the u. And we will do the derivative of what we just wrote. The derivative of 2x cubed would be 6x squared. The derivative of 3 would be 0. And then we want to manipulate that, like on the previous problem. Multiply by dx, divide by 6. Now look, this one says x squared dx. And so we'll replace the x squared dx in the integral with a 1/6 du. We can do this integral by copying down the 1/6 and doing the power rule. A little bit of simplifying and change the u back into 2x cubed minus 3. So to do substitution on this, we're going to choose our u to be the exponent of the e. We're going to do the derivative of that. And then match up the rest of the problem. Notice how we've got an x dx. Over on our du, if we multiply by dx and divide by 2, there's x dx. So we want to replace the x dx with a 1/2 du. This is our integral. To do that integral, we copy down the 1/2. The integral of e to the u is e to the u. We change the u back into x squared. Now for this one, we're going to choose u to be the denominator of the fraction. And do its derivative. And then match up the remainder of the integral. Multiply the derivative by dx, divide by 2, and we'll replace the x dx with a 1/2 du. The integral of 1 over u times 1/2, if we copy down the 1/2, the integral of 1 over u would be the ln of u. We change the u back into 4 plus x squared. Now the absolute values are not necessary on this one because 4 plus x squared is always positive. Now I won't be working these problems through. However, if you've caught on to what we've done on the last several problems, you should be able to recognize what you're going to be starting out choosing for your u. On this first one, we want to choose u to be the stuff inside the square root. On this one, we want to choose u to be the exponent on the e. On this one, we want to choose u to be the denominator of the fraction.